How to calculate relative atomic mass. So if you look at a periodic table, you'll see there are two numbers on, for example, chlorine. There's the atomic number, 17, and there's the relative atomic mass, 35.5. And the question is, how can you have a mass of something that's 35.5 because you can't have 0.5 of a proton or 0.5 of a neutron? So the answer is, there are two versions of chlorine. There's chlorine 35 and there's chlorine 37. And chlorine 35 and chlorine 37 are isotopes of each other. They have the same number of protons, 17 and 17, but they have different numbers of neutrons. So in the case of chlorine 35, there are 18 neutrons. In the case of chlorine 37, there are 37 minus 17, top number minus bottom number gives you 20 neutrons. So on planet Earth, 75% of all of the chlorine is chlorine 35 and 25% of all of the chlorine is chlorine 37. And you'll be given these percentages in the exam. So to work out the relative atomic mass of chlorine, you have to use a weighted average. So what we say is 75%, which is 75 divided by 100 times by 35 plus the percentage times the mass of the chlorine 37, which is 25 divided by 100, because it's 25%, which is 25 divided by 100, times by the mass of that one, which is 37. And if you put that in the calculator, the number that comes out is 35.5. This means the relative atomic mass, i.e. the average mass of chlorine, is 35.5. So there's a similar case for magnesium. There's magnesium 24, there's magnesium 25, and there's magnesium 26. And on planet Earth, 79% of all magnesium is magnesium 24, 10% of all magnesium is magnesium 25, and 11% of all magnesium is magnesium 26. So to work out the relative atomic mass of magnesium, we add up 79% times 24, 10% times 25, and 11% times 26. So if you put these calculations into your calculator and you're careful, you'll get a number out which is 24.3. So the relative atomic mass of magnesium is 24.3.